When we started Nile, my co-founder and I, we really wanted something that will signify we're building a platform. So for us, having this major river, major artery that things were built on top of was a very good analogy.
The most valued guy from my perspective was the one that built the Argo CD, the Jenkins pipeline, the Kubernetes cluster, all of that, because in the end, it was literally you commit to your Git repository, you make a new tag, the build pipeline picks it up, the deployment pipeline picks it up, and you're literally just magically have the new version deployed. And it was incredible.
So we were like, how do we isolate them? How do we give them privacy and security? How do we give them each one the performance they need? How do you scale up as the number of customers grow, which is different than scaling up as a single customer growth?
Hello, everyone. Welcome back to this week's episode of simplyblock's Cloud Commute podcast. I'm not saying I have another incredible guest because today I have an actually super incredible guest, very special. Don't laugh. You know it's right. Gwen, it is a pleasure to have you. I don't want to say that all the other guests are like boring, but to me, you are actually special. So thank you very much for being here. Maybe just tell us a little bit about yourself. Who are you? What you do? And we'll take it from there.
Thank you. So first of all, thank you for inviting me, and I'm super duper excited to be on your show. I'm currently co-founder of Nile, where we're building serverless Postgres for SaaS. And before that, I spent almost 7 years at Confluent. So Confluent, for those who haven't heard, it's the Kafka company, essentially. There are a bunch of Kafka companies now,
True.
and it's probably very not Apache-ly correct to say that, but it was a company founded by the people who started the Apache Kafka project and had huge investments in the Apache Kafka project over the years. I was there from when I was like employee either 10, 11, or 12. We joined 3 of us at the same day, so I will never know. And by the time I left, it was thousands of employees. So that was quite a journey. I did a lot of different roles. I joined as an engineer. I moved to product. I moved to marketing. And then I moved back to engineering. And then I did some engineering management. So I got to experience the ride, which kind of helped me prepare to start my own company in some ways, especially the stint in product and marketing. And then before that, all of my background is basically in data. I started at HP, and then I worked on Oracle for a very long time. I did some MySQL, Hadoop, and then it was Confluent and Kafka. So I have a long career. Just the way I like saying it is spent the last 20 years moving data from place to place, and I'm not done yet.
You see, exactly that's the reason why I say you're a very special guest to me, because I know you mostly from Twitter, these days X, and I've never seen you talk about anything but data, and that is amazing. Any kind of database, any kind of, as he said, data movement, data placement, whatever. And I specifically love all your engagement with the different communities, asking questions, actually meaningful questions. I think that is very different from a lot of other people. As I said, thank you for being here. It's awesome. I'm the one who's excited. You talked about Nile. I always want to say Neil, the German pronunciation of it. We talked about that before in the pre-run to that session. Maybe tell us a little bit about Nile, your serverless Postgres installation, and why it is called Nile and not Neil.
Yeah, the name question. First of all, I'm from the Middle East, so I kind of grew up with the Nile and stories about the Nile and so on. And for me, it's kind of the bedrock of what used to be a giant empire, and it's still the bedrock of so much commerce and so much life that has been going on around it. And when we started Nile, my co-founder and I, we really wanted something that will signify we're building a platform that businesses and things in general, a life will be built on top of that. So for us, having this major river, major artery that things were built on top of was a very good analogy. I would also point out, completely coincidentally, Nile is slightly longer than Amazon.
That is important. I get that.
It is slightly important, yes. So, yeah, so we like the name. We like that it was 4 letters. It's short, it's memorable, so it has good things for a company name. And we actually iterated over several ideas. So we started the company with the idea that, hey, at Confluent, building Kafka took N people. Building the entire cloud services, the self-serve, the SaaS on top of Kafka, it was like 3x people. It was much harder. And this was a surprise to me. I was always, as I said, like I was always into building data infrastructure. I saw this is hard. And this is really hard. I didn't realize that there is something that is actually much harder that comes on top. So we really wanted to build something that will reduce the overhead of building these services around the service. And our first iteration was a control plane. We were not very happy with that. We didn't find a lot of other people who were happy with it. And then we were thinking that actually the kind of problems we wanted to solve about managing multiple tenants on the same platform, which is the core problem of SaaS. How do you provide one service to a lot of customers with very different needs and very different requirements, very different workloads? So we were like, how do we isolate them? How do we give them privacy and security? How do we give them each one the performance they need? How do you scale up as the number of customers grow, which is different than scaling up as a single customer grows? So we took all those ideas and we were like, actually the right layer to solve those is in the database. The idea is that what you actually need to isolate is data access. All the authorization, authentication, those are all data level concerns. They should be enforced close to the data. And performance it has a lot of factors, but obviously the database is major in allowing companies to scale. And you see it in blogs again and again. Things like flexibility. Can you customize your product for one customer versus the other? A lot of times it also ends up being a database concern. So we're like, okay, we have to take a good solid database that is open source and adopt it to the concerns of people building software as a service, because those are not adequately addressed today on the data layer.
And you took the only meaningful option, which is Postgres.
We like Postgres a lot. I mean,
get
if you're
that.
going to do a serverless database and kind of host it and manage it, you cannot pick a database that you don't really, really like. And you have to believe that it is the best database ever. Otherwise, it's hard to run something as a service for other customers. If you don't believe that you are really choosing something solid, it's probably impossible.
I would totally agree with that, and I'm a big Postgres fan myself for all the same reasons. Just quickly, the Postgres ecosystem is massive. There's like so many extensions. I guess you can run extensions on Nile.
So you cannot pick your own extensions. We may get there at some point, but we're not quite there, and partially it's because of the we are currently still limiting what people can do. You also cannot even run your own functions at this point. We will get there. We are still only a year or two into the startup journey. But at this point, what we are doing is taking popular extensions and baking them into Nile. So our customers pick up the phone or realistically pick up their Discord and say, hey, we need this extension, PostGIS, PG Vector, all those things. PG Crypto has been super popular. And we're like, okay,
Hopefully.
we're on it. And we're also writing our own extensions. We have, obviously, Nile itself is an extension. And we also have team members who have their open source extensions that are quite popular. So
right,
it's
right. I think that is a totally fair approach. And I guess a year in, you probably have most of the extensions that people want anyway. So we're probably good on that side.
we definitely try to be responsive to customers. This is
Right.
important when you're a startup.
Right. So you mentioned that you're building your own extension. You say serverless Postgres. Postgres by itself isn't really serverless. So what would you say was like the biggest like challenge hurdle you had to overcome to make Postgres serverless?
You know, it really scares me to answer this question because deep down, I feel like we have not met the biggest challenge yet. I feel like it's the other shoe is about to drop. I feel like it's still ahead of us. So I'm a bit. I would want to qualify the biggest challenge to date.
Mm-hmm.
We don't know what we don't know, and this is maybe the scariest part. Um, I think there are two things that were challenging and they're actually intertwined, maybe three things. So one
Mm-hmm.
of them is the transactional guarantees.
Mm-hmm.
We want to a big reason that people pick Postgres and not MongoDB is that it's a relational database with a strong ACID guarantees. Postgres is actually one of the best databases in terms of transactional guarantees. When you say serializable, it's snapshot serializable, which is better than snapshot isolation. It has better guarantees. So they did so much good work. We have to work in it, and it opened up a lot of questions. Can you have a transaction that involves multiple tenants, or do you limit transactions only to one tenant? How does it work as you try to scale? So dealing with those concerns, we choose to take limitations. Your transactions have to be for a single tenant at this point. So
Mm-hmm.
we don't let you transactionally update an entire table with all the tenants in it. Some people don't love it, but we feel that this is the bread and butter of SaaS, isolating the changes to individuals.
What would you do writing over multiple tenants? That sounds scary.
Yes, and when we allow it, we found that customers often regret it. Like the number of times that you deleted or updated an entire table because you unintentionally left out a where clause is distressing.
Right.
And so we are opinionated to an extent in preventing people from shooting themselves in the foot. So dealing with the transaction limitations has been an interesting experience. Distributing, so there are things that do have to get distributed to all the tenants. So for example, no matter how much we isolate tenants to their own databases, if you are adding a new column to a table, you need every single
Yeah.
tenant to have this new column. So dealing with those distributed DDLs has been really interesting. Storage is interesting, and I think the interesting bit is how intertwined everything is in Postgres. Because if we want to have the tenant isolation on the storage layer, which we really want, because this is the magic that allows us to move tenants to new machines as you get more and more customers, we can kind of auto shard it for you and spread it out.
Mm-hmm.
This means that every data block has to know which tenant it belongs to. Every record in the WAL log has to know which tenant it belongs to. So it's kind of a big rabbit hole that you go down. Transactions in the commit logs, they have to know which tenants they belong to. So it's been an interesting journey, and as I said, I don't think we're at the end of the journey at all at this point.
All right, that's fair. I think if you're making such a big change to a system which is not designed which wasn't built, not necessarily not being designed for it, but it wasn't like a thought when they created the actual system. So that is really interesting. I think it's always fair to say we don't know where the road is ahead, because almost nobody did this before. There are some others that say serverless Postgres, but I think it really depends on how you actually define serverless or not.
Yeah, defining serverless is another rabbit hole. I only build serverless. I don't try to define it.
That is true. So as a developer, how would I get started? I mean, it is Postgres, so I guess any Postgres client works for me.
And absolutely any Postgres client, any ORMs that you enjoy. We tested with the popular ones, so I can tell you and we have examples. Like, as you probably know, we share a deep passion for developer experience and really making sure that developers of all kinds, experienced, beginners, this language, that language, meeting developers where they are is so important. So we have tutorials for any ORM, any popular ORM, if you like Prismas and Drizzles and SQL Alchemy and Hibernate. We have Django. We basically try to cover everything that people use and just give a small example. And you use it completely normally. There's only two tricky bits that you need to get. Nile shows up with some tables already built in, like the tenants table. You need to pull them into your ORM and generate an object from the database, which is something that some developers haven't done before, but is actually very easy in every ORM. And the other one is that you need in a transaction to specify which tenant the transaction is for, because that's the entire point. And this is the main point of most of our examples. Here is the snippet of how you specify the tenant in Prisma, in Hibernate, in Drizzle, and so on. And we kind of tie it end to end because we are very SaaS focused. We believe that the tenant will probably be a header in an HTTP request. There will probably be a jot or a session with the user. So we can tie the HTTP header down to the transaction. We can tie the user down to the transaction. We can validate that the user actually has access to the tenant that is mentioned in the transaction. So this is the whole point of pushing all this information from the browser, from the layer, all the way down to the database, so we can do these kind of things.
Right. Okay, cool. And I can just go to, what is it? The Nile. Help
The
me real quick.
Nile.dev.
Dev, right. I knew it was not IO. The Nile.dev.
Yeah, we can. IO was probably free, but we thought that especially since we didn't start with the database, I think we thought that IO is, we're not really dealing with IO. We are all about
Okay, fair enough. So the Nile.dev, and I sign up for an account and I get all the credentials I need.
Exactly.
All right. So we're a cloud podcast. So who would we be not to ask the question of all questions? Like, how does that look like backend wise? I mean, we're talking a lot about Kubernetes here. And
yeah, we actually migrated to Kubernetes fairly recently. So we started out with just ECS. So a bunch of EC2 machines, some Pulumi scripts to deploy stuff on them. And it worked for us for a very long time. It got really messy as we added more services. It got pretty messy to do releases. And that's when we moved to Kubernetes. And we now have Helm charts. We have Flux CD. So everyone with a service can basically upgrade the version. It actually happens automatically. So you kind of merge and then it triggers a bunch of tests. It deploys to dev. It opens a pull request to upgrade production. And if you merge the pull request, it kind of goes on. So we have a fantastic infra engineer who just set it all up. Good infra engineers are just so I think understated. Like they take for granted the fact that they actually do quite amazing things, and they're like, no, this is obvious. This is how you do work. But then for me, it's like, oh my god, it's all magical.
I think I completely agree with you. It was the same with my startup. One of the most valued, and I'm not saying that all the other guys were like really bad, but the most valued guy from my perspective was the one that built the Argo CD, the Jenkins pipeline, the Kubernetes cluster, all of that. Because in the end, it was literally you commit to your Git repository, you make a new tag. Uh, the build pipeline picks it up, the deployment pipeline picks it up, and you're literally just magically have the new version deployed. And
Yeah.
it was
And it
incredible.
saves other engineers so much
Yes.
time. Like the way it's just this giant force multiplier, and it prevents all kinds of random incidents, um, possibly generate some new ones. But I think on the balance, it's just been pretty amazing.
I think the problem is that a lot of that is fairly invisible. It's kind of the same problem we had in the past where front end engineers were like the ones everyone loved, or graphic designers because they had something to show. And as a back end engineer, you were the one like, yeah, I'm working on that for like weeks. Show me.
Yeah, it's really hard, and especially in larger companies where you have
Yeah.
formal like performance reviews and performance calibrations across the company. There is this thing where you have to show the impact of an engineer, right? And on one hand, you have this front-end engineer who moved the bottom 2 pixels to the left, and suddenly conversion is up by 50% and huge impact on the entire company.
Yep.
But what he did is move a pixel by a few pixels. And on the other hand, you have someone who completely rewrote a core part of the storage engine to be 30 times faster and 100 times more reliable. And okay, but what was the impact? Well, customers no longer lose data and they're slightly happier because it's faster.
Yes, yes. That is so true. It's so sad. Um, I've been there in my career at least once, probably
Yeah, I
more than
do think
that.
that infra engineers should not work for large companies. I mean, it's tongue in cheek. Obviously, a lot of them are very happy at Google and AWS, but I do feel like if you want to be noticed for your impact, a small company is so noticeable because everyone is an engineer. Everyone sees what you're doing.
But I think that is in general. I mean, with simplyblock, we're super small startup still, around like 16, 17 people, and I chose to go back to those like small company environment exactly for that reason, because you have influence. You really matter still. You're not just a number. um
Yeah, and like, how did we even move to Kubernetes? Well, we hired the infra guy, and he talked to developers, and they're like, "Oh yeah, this sounds like a good idea. Let's try it." And then he did it, and everyone's like, "Oh yeah, this is so much better. Okay, we're going."
Awesome. Yeah, that is, you see, that's the impact I'm talking about, right? He came in, he made a suggestion, and you say it was a good idea. It's great. It's much better than it was before. Um, one thing, because Simplyblock is a storage company, you mentioned that storage is a problem for you. In what sense?
Yeah, I mean, so I wouldn't say that storage is exactly a problem, but it is a part of Postgres that we had to figure out how to modify, like
Hmm.
find the spare bits in the block where we can put tenant identifiers, kind of
Ah,
thing.
right. Okay.
But I would say that in general in the industry, if you look at incidents across the board, and there has been plenty of research, storage outages are kind of a leading cause of outages.
Hmm.
And obviously, storage performance has gigantic impact on the performance of any system. You can only get worse than your storage. Your performance cannot really get a lot better than your storage.
That's true.
So this is kind of a major thing, and I think the idea of tiering storage, which is something that I think Confluent kind of pioneered, and I wasn't on the teams that pioneered it, but I was fairly close to it. The idea is that you have some data that has to be on expensive disks and very fast, and some data that you may have to be high throughput and very reliable, but speed is like low latency is not exactly the concern, and maybe actually having a lot of copies is more important. Like this is I think one of the most important ideas when it comes to serverless and when it comes to building cloud native systems.
Okay, I think that is a perfect answer. I could not add anything to that. I mean, who would I be anyways? All right. We already crossed the 20-minute mark by a
As
few
usual.
minutes. um, so we like the last question for every guest. Like, what do you think is like the next big thing? Could be database, could be a lot of people talk about AI. Could be anything you like to
Yeah,
talk
I'm
about.
kind of struggling to think. As much as I want to talk up the future of databases, I'm struggling to think of anything better than bigger than AI going on.
Mm-hmm.
One of the big questions is whether the idea of RAG, of vectorizing data, storing it in a database, and using the vector similarity to enhance
Mm-hmm.
the performance of AI, whether this is here to stay. Every indication tells me that the concept is here to stay and the techniques are just getting better and better, both in terms of embeddings and also techniques outside of embeddings. And I also see PG Vector keeps getting better and better, and a lot of contributions. Performance improvements are going in, new indexes, improvements to indexes.
Right.
So I feel like watching, and I don't know that vector data, I know it's controversial. There's a lot of people probably listening with a vector database. I don't know that there is tons of appetite, especially in small startups where a lot of the AI is happening in small startups, whether there is a lot of appetite for yet another database versus I'm seeing so much, just let me do everything in Postgres. And if Postgres is few percent point maybe slower than the absolute leading edge vector DBs, I think a lot of people will absolutely take the bargain because just let me do everything in my Postgres. So I do think that, RAG is here to stay. Vector similarity is getting better and better and faster. And I do think that PG Vector is going to own a huge slice of it.
All right, cool. Yeah, I think that is a very nice last sentence. Rack is here to stay. Thank you very much. We are at 26 minutes. I think we have to cut it here. Yeah, thank you very much for being here. Awesome chat, just like the previous, like the pre-recording, or not pre-recording, the pre-chat we had. It is such an honor to have you. Actually, as I said, I'm the one who are excited here, so thank you very
Uh,
much for being here.
Thank you so much. It's been a pleasure.
All right, and for the audience, you know how it rolls. Same time next week, same place. I hope you're coming back and you listen in again. Thank you very much for being here as well.